Welcome to EDU World Space.
To sketch this, the first thing I would do, I wouldn't necessarily try to plug in values directly into here, because if we were to let this be x, let this be y, notice we could go ahead and actually solve this exactly for y is equal to something. One thing we'll need to keep in mind is that x has to be strictly larger than 0, and y also has to be strictly larger than 0. When we're plugging these in, because remember, e to the 2t and e to the t never equals 0. Yeah, let's go ahead and use this to help us out. So first, this x is equal to e to the natural, or e to the 2t. I'm going to take natural log on each side, so that'll give us natural log of x is equal to 2t. Then we can divide over by 1/2, so we have 1/2 natural log of x is equal to t. And then we can use the power rule for logarithms to pull that inside. So we have natural log of x to the 1/2, which is the same thing as natural log of the square root of x is equal to t. Now, let's use this fact here that y is equal to e to the t. And now we're just going to take this, plug it in for t. So it's going to be e raised to the natural log of the square root of x. The e and natural log cancel out, and we're just left with y is equal to the square root of x. Now, this is something that's a lot easier for us to graph than this, like x is equal to e to the 2t and y is equal to e to the t, because we know what a square root function looks like. And one thing we have to keep in mind is that x, y has to be strictly larger than 0, because normally we can plug in y or x is equal to 0 into here, but due to what our function was originally, we won't be able to do that here. So let's go ahead and plug these in now. So, well, let me make this a little bit bigger. 2, 3, 4. 1, 2, 3, 4. Okay. So we'll have no negatives. Now, normally we could plug in 0, but this time we're going to have an open circle at 0, 0. And then we'll just have the normal values for a square root function, which will look like this here. And one thing we could also do is go ahead and plug in the direction, or not plug in, draw the direction of this. So let's just go ahead and plug in 0 and then plug in 1 and then see which way it's going to be going in. So I'll do this off on the side here. And actually, we already need to figure out what is r of 0 anyway, so we'll kind of kill two birds with one stone by doing this. So first, r of 0 is going to be, well, we're just going to plug 0 in for t. So that would be e to the 0, which would be 1i. So 1i plus, and then that would also just be 1j. So that would just be I plus j, or this is just the point, or the vector 1, 1. Okay, so we know we're at this point here. Then, if we were to plug in, or actually, we can kind of just think, well, we know if we're going to negative infinity, then both of these goes to 0. So as t gets very negative, it would just be getting closer and closer to 0 for both of those. And because of that, that would kind of tell us that we would be going in this direction here. So I don't know if that's necessarily needed to do, but I think it's always good if you have any kind of vector to just go ahead and actually list out what you have here. Let me just get rid of that. Or list out the direction. There. Now, the next thing we want to do is go ahead and find the derivative. So we're just going to take the derivative of each of these components. So actually, let me just write this out down here. So r of t is equal to e to the 2t I plus e to the t j. Now, if we take the derivative of this with respect to time, or with respect to t, we have r prime of t is equal to, so I'll just kind of write this out. So d by dt of e to the 2t, and then we can pull out that I hat because it's just a constant, plus d by dt of e to the t, and then we pull out the j out because it's a constant, and then the derivative of e to the 2t. is going to be 2e to the 2t I hat plus, and then the derivative of this over here is just going to be e to the t, and then we have j hat there. So this is our derivative with respect to t. And now to go ahead and finish off C, we need to sketch r prime of 0 and r of 0, where we would just need to go ahead and now find what is r prime of 0. So actually, let's look back down here. So we just need to take 0 and plug it into here. So we would end up with 2 times 1 times I hat plus 1 times j hat. So that would just be 2i plus j, which ends up being 2, 1. And now to actually graph these two. So first, the vector 1, 1 is just saying x is equal to 1, y is equal to 1. So we're going to start from the origin and then go to our point. So this is going to be r of 0. And then since this is supposed to be the tangent vector, I'm going to actually graph this on the point here as opposed to like starting from the origin. So this is going to be, so we want to go 2 in the x direction because it's saying 2x, 1y. So we go 2 in the x direction, so 1, 2, and then 1 in the y, so it would be around here. And then this, or actually maybe I should do this in a different color. I'll do this in red. So this here is going to be r prime of 0. So this is our sketches for A and C. And then our derivative would be down here.